Hello guys, welcome back to another video of science. Today we'll be looking at waves. What is a wave? A wave is a way in which energy can be transferred between stores. It can transfer energy and information without any net movement through the medium which they travel through. On the right we can see a typical wave and these wavelength crests, one complete cycle, trough and amplitude. We will be learning about them in due course. Also, they involve oscillations and vibrations. So, amplitude is the maximum displacement of the wave measured from the middle. So, this is just an insight to what it is. Trough, a trough is the lowest point of a wave, and a peak is the highest point of a wave. The types of waves. There are two types of waves: transverse waves, in which the particles vibrate. The vibrations causing the wave is at right angles to the direction of energy transfer. And then examples are EM waves, seismic S waves, water waves. So when we say water waves, we mean like ripples on a water tank, something like that. So for a longitudinal wave, the particles vibrate parallel to the direction of the energy transfer. Examples are sound waves, ultrasound waves, and seismic P waves. Properties of waves. So a peak is the tip of a wave, a trough is the bottom of the wave. Wavelength is the length of one full wave, so from one peak to the other, for example, is measured in meters, or can be one point of the wave to the same point on a different wave. And amplitude is the maximum displacement of the wave from the middle line. The greater the amplitude, the greater the energy of the wave. And the frequency is the number of times per second the wave cycles, and the frequency is measured in hertz. The period of the wave is time taken to produce one wave, time between wave crests. The period of frequency are closely related to each other in a formula which is whereas period is 1 over frequency. They're reciprocals of each other. The speed of mechanical waves, so the speed of waves, depends on the medium it's traveling through. So it's like whether it goes through water, air, so they're different mediums. So it's faster in air than it's in water. So sound will travel at a different speed in water than in air. So final point is the wave equation, which states that speed of the wave is frequency times wavelength. So here we can see V equals F times lambda. So wavelength is measured in lambda, which is a Greek letter. So now we'll be looking at reflection. So here's a diagram of refraction. So here we have the angle of incidence and the angle of reflection. So the angle of incidence is the angle between the incident and normal. Reflection is between normal and reflected. Always the angle of incidence is the angle of reflection. That's the rule. The normal is a 90 degrees line drawn up where the surface meet or incident. So mirrors work by reflecting light. A mirror with a flat surface is called a plane mirror. We will be learning about a reflection of a flat surface and a rigid surface, so specular and diffuse reflection in the next coming slides. So an image in the mirror is upright, the same size as object. Distance from mirror to object is the distance from the image to the mirror. It's laterally inverted and virtual, means it can't be represented on a screen. So here we're going to talk about the reflection and the virtual image. So reflection can be very useful. So at night, cyclists wear like kind of vests which like high visibility, which reflect off the light and make sure that the cyclists get noticed and to prevent accidents and so the cyclist is safe. In a virtual image, the rays appear to diverge from behind the mirror, so the image appears to come from the behind the mirror. So we can see on the right, we can see the human eye looking and how the image is shown that it's coming from the back of the mirror. So we learn about speculative reflection, which is reflection of a smooth surface. Now we'll be learning about diffuse reflection, which happens if a surface is rough. Diffuse reflection happens instead of forming an image. The reflected light is scattered in all directions. This may cause a different image. To add, which I haven't mentioned in this, so we'll be talking about ways of measuring wave speeds. So how to measure wave speeds. So in a lab, we should take account of the equation speed is distance traveled divided by time. So the problem with measuring speed in air is that sound travels quickly. So in a lab, we need loudspeaker, 2 microphone, and an oscilloscope. And then we have to see the time difference between microphone A and microphone B. And the loudspeaker is connected to a signal generator which produces short pulses of sound. And then 2 microphones are placed in the loudspeaker but separated by a short distance. And then once we get the trace from the microphone, we can see the speed. So distance traveled divided time taken. The other way is measuring the speed of sound outside. So we use echoes. So echoes from a building can be used to measure. And then so you stand 40 meters in front of a tall building and bang 2 blocks of wood together. So each time you hear an echo, bang the blocks again. And then it's a job done by 2 students. So the other students use a stopwatch at time. And then you get the first trial and then you do timings. Thank you for watching. Like, subscribe, and look out for my Waves Part 2 and maybe even Part 3. Thank you for watching.